Energies of atomic orbitals. Electrons are one of the three subatomic particles. They have a negative charge and about 1 by 2000 the mass of a proton. They are attracted to the positively charged protons in the atomic center, but they are repelled by one another. It is impossible to absolutely define the position, momentum and location of an electron in space and time. Instead, electrons are described as having different probabilities of distribution around the atomic center. These volumes of space, where an electron is found more often, are called atomic orbitals. Atomic orbitals have different shapes. All s orbitals are spherical. Electrons in s orbitals have the same probability of being found in any direction and at a given distance from the atomic center. In all other types of orbitals, occupying electrons have no probability of being found at the center. All p orbitals are shaped somewhat like a dumbbell, with the thin, pinched region of zero probability lying right over the center. No matter what its shape, an orbital can only hold a maximum of 2 electrons at any time. Orbitals are grouped in zones at different distances from the atomic center. Electrons in zones close to the center are lower in energy than electrons in zones at greater distances from the center. According to Bohr, the amount of energy needed to move an electron from one zone to another is a fixed, finite amount. These zones are known as energy levels, or sometimes called electron shells. At the lowest energy level, the one closest to the atomic center, there is a single 1s orbital that can hold 2 electrons. At the next energy level, there are 4 orbitals: 2s, 2p1, 2p2 and 2p3. Each of these orbitals can hold 2 electrons, so a total of 8 electrons can be found at this level of energy. In larger and larger atoms, electrons can be found at higher and higher energy levels. Example, 3s and 3p. As Niels Bohr showed, it is possible for electrons to move between energy levels. Light contains energy. If a photon of light strikes an atom, it is possible for the energy in the light ray to be transferred to one of the low-energy electrons moving around the atomic center. The electron, with its extra packet of energy, becomes excited and promptly moves out of its lower energy level and takes up a position in a higher energy level. This situation is unstable, however. Almost immediately, the excited electron gives up the extra energy it holds, usually in the form of light, and falls back down to the lower energy level again.